Still on unit rate, but we're gonna look at a different type of problem. Um, you're in seventh grade mathematics, going into eighth grade, hopefully. So you're not always gonna have whole numbers to deal with. Sometimes the numbers they give you, they're gonna be decimals or fractions, and we have to know how to work with those type of rational numbers. Now, mind you, we stick to the script, all right? Nothing changes. It's just that we're dealing with different types of numbers, different types of rational numbers, but the steps are still the same. So let's take a look at this problem here. All right, it says an Olympic swimmer can swim 32.5 meters in 80 seconds. How many meters can this swimmer swim per second? All right, so I'm going to move a little faster now because this is your third example. So step one, recognize my units. Okay, from here, I could see that it says an Olympic swimmer can swim 32.5 meters in 80 seconds. So automatically, I know that my problem, or this problem, is expressing meters and seconds. Remember, I need these two units for my proportion. Step two, I'm going to use the info to set up the left side of the proportion. So if I read it again, this is the second time I'm reading. An Olympic swimmer can swim 32.5 meters in 80 seconds. Okay, here's my first problem. I have a fraction. And the problem is not a fraction, it's what type of fraction is. It's a mixed number. We don't want to use mixed numbers. We have to convert this mixed number into an improper fraction. And the way we do that is we have 32.5. All right? So we do 32 times 2, and we get 64. Now we take that and we add the 1. So we have 65. So 32 times 2, we have 64. And now we have to take this 1 right here and add it to that 64. And we have 65. And we keep the same denominator of 2. So as a mixed number, it's 65 over 2. All right, so now we've changed that. So now instead of 32.5 meters, it's 65 over 2 meters. So I'm going to use the info to set up the left side of my proportion. So I have 65 over 2 meters. All right, all I did was change the 32.5 into an improper fraction over 80 seconds. 80 seconds. So I haven't done any math yet. I turned 32 or converted 32.5 into 65 over 2 meters. So in 80 seconds, the swimmer can swim 32.5, which is converted to 65 over 2 meters, all right? So we have a full fraction in our numerator. So that's our left side of our proportion, all right? Step 3, reread the problem, what don't I know? Okay, it's asking me how many meters? How many meters? So obviously we don't have meters. Can this swimmer swim per second? Oh, here's our per. And we know that per means for 1 second. All right, for 1 second. Excuse that second there. Okay, so how many meters can this swimmer swim per second? So my seconds right here on the bottom. This is why units are important. Seconds on the bottom, so I'm going to put 1 second because that's what we want to know. We don't care about 80 seconds, but the information is helpful. We want to know in 1 second how far can the swimmer travel. And we don't know, so we put a variable, our x. And now we are all set up. It may look a little weird because there's a fraction in the numerator. All right, it's not a whole number, it's a fraction, but we do the same things. Okay, so now let me get rid of all this here, and now let's solve this proportion. All right, so I'm going to rewrite this. We have 65 over 2, and this is meters. Remember, this was 32.5. All right, and it goes that far, or he swims that far in 80 seconds. 80 seconds, I'll abbreviate. equals, we have our x on top because we don't know how far the swimmer can swim in 1 second. Sweet. All right, so let's get rid of this down here so we have some space to work. All right. So now we have a proportion. The same thing, we cross multiply. We do our x term first. I have 80 times x, that's going to give me 80x. Okay, done, which is also equal to, I have 65 over 2 times 1, that's going to give me 65 over 2. Okay, I haven't done anything different. I'm still sticking to the script. All right, so now I want to know what x is, all right? I don't care about what 80x is. I need to get rid of that 80. The only way to do it, we divide by 80, and 80 divided by 80, that crosses out. That's going to give me 1x, or just x. Remember, 1x is the same as x. Is equal to, now I have a fraction. Whenever I have a fraction on this side and I'm dividing fractions, I know usually we would say, okay, we divide by 80 here, and now we divide by 80 here. But that looks a little weird to me, so I'm not going to do it that way. Okay, remember, there's different ways to show division. So instead of doing it that way, I'm going to divide by 80 here like we did, and just divide by 80. All right? And that looks a little weird, but we know I can make any whole number a fraction by just putting it over 1. So now, once we do this, we have a basic fraction division problem. All right, so this is our problem. This is how we have to calculate this to find x. So I know my rule when dividing fractions. I keep the first fraction, so 65 over 2. I change the division sign to multiplication sign, and now I take the reciprocal of the second fraction. It is 80 over 1. I'll make it 1 over 80. And now I just multiply. So 65 times 1 is 65, and 80 times 2 is 160. And this is my answer. But what does this answer mean? Remember, we plug this answer back in for our x. So we know the problem told us in 80 seconds the swimmer can swim a distance of 32.5 meters or 65 over 2 meters, but in 1 second the swimmer can travel 65 over 160 meters. Which is less than 1 meter. And there we go. We have our unit rate for how far the swimmer can swim every 1 second. MathSoEasy.com. I'm out of here.